Hey everyone, welcome back to the networking series. In this video, we're going to talk about routing fundamentals, the essential process that allows data to travel from one network to another. Routing is quite frankly what makes the internet work, and understanding how it works is the key to managing and optimizing any network. By the end of this video, you'll know what routing is, how routers work, and why it's so important for network communication. Let's dive in. So, what exactly is routing? Simply put, routing is the process of determining the path that data takes to reach its destination. When data moves from one device to another over a network, it doesn't just take a straight line. It follows a specific route, and that route is determined by a device called a router. A router is a device that connects different networks together and forwards data packets between them. Think of a router as a traffic controller. Just like how a traffic controller directs cars on the best path to get them from point A to point B, a router directs data on the best path through the network. When data is sent across a network, it's broken down into smaller units called packets. Each packet has a destination IP address, and the router's job is to examine that IP address and then determine the best route for the packet to take to get to it. It forwards the packet from one router to another until it reaches its destination. But how do routers decide which route to take? This is where routing tables come into play. Every router has a routing table, which is like a map of the network. The routing table stores information about different routes that help the router decide the best way to send the packet. It includes details like the destination network, the next hop, which is the next router along the path, and the cost or distance of the route. Routing decisions are made based on various metrics, such as the hop count, which is the number of routers a packet has to pass through, or the bandwidth available on a route. The router selects the best route based on the lowest cost, which often means the route which has the fewest hops or the highest available bandwidth. There are two main types of routing: static routing and dynamic routing. Static routing is where a network administrator manually configures routes in the router's routing table. This method is simple, but not very flexible. If the network changes or a router goes down, the static routes won't automatically update themselves. Static routing is best used in very small networks where routes don't change often. Dynamic routing, on the other hand, allows routers to automatically learn and update routes using routing protocols. These protocols help routers communicate with each other, share information about available routes, and adapt to changes that may occur in the network. Dynamic routing is much more flexible and is used in larger, more complex networks. There are several dynamic routing protocols, but the most common ones include RIP, pretty old, not used a lot anymore, OSPF, EIGRP, and BGP. Let's take a quick look at each of these. RIP, or Routing Information Protocol, is the oldest routing protocol. It uses hop count as its only metric and has a maximum limit of 15 hops, which makes it less suitable for large networks. OSPF, or Open Shortest Path First, is a more advanced protocol that uses a cost metric based on bandwidth of the links. It's more efficient than RIP and is widely used in enterprise networks. One of my personal favorites is EIGRP, or Enhanced Interior Gateway Routing Protocol, which is a Cisco proprietary protocol that improves on RIP by considering multiple metrics like bandwidth and delay to determine the best route. And finally, the big daddy of them all, BGP, or Border Gateway Protocol, is the protocol that powers the whole internet. BGP is used to exchange routing information between different autonomous systems, or ASs, which are large networks managed by different organizations. It's essential for determining the best routes across the global internet. Now, let's talk about the concept of default gateways. In most networks, devices like computers, printers, and phones use a default gateway to send data outside of their local network. The default gateway is the router that connects the local network to other networks, like the internet. If a device doesn't know how to reach a particular destination, it sends the data to the default gateway and the router takes care of forwarding it from there. Another important concept is NAT, or Network Address Translation. NAT allows multiple devices on a local network to share a single public IP address when communicating over the internet. The router uses NAT to translate the private IP address of the devices into the public IP address of the router, and vice versa. We'll go deeper into NAT in a following video. Let's also mention routing loops, which can happen when routers send packets in a circular loop between themselves. This can occur when routing tables become outdated or misconfigured. Routing protocols use techniques like split horizon and route poisoning to prevent loops. They can be nasty. So, to recap, routing is the process of determining the best path for data to travel between networks. Routers use routing tables to store information about available routes and can make routing decisions either statically or dynamically using routing protocols like RIP, OSPF, EIGRP, and BGP. Default gateways and NAT play crucial roles in connecting local networks to the internet and managing IP addresses. In our next video, we'll be diving into Network Address Translation, or NAT, and how it allows multiple devices to share a single public IP address. Make sure to subscribe so you don't miss it. Thank you all for watching. I really mean that. Thank you for every click. I truly do appreciate it. Don't forget to like, comment, and subscribe, and I'll see you all in the next video. Take care.